basic thing. So the F3 that we just did was really an overview of linear functions. You need to know that for calculus and everything real well. So a linear function, we've already talked about that. You're used to that. Y equals mx plus b. We just say f of x equals mx plus b. The slope is an average rate of change. We've talked about that. And just think of this as the distance between the y's over the distance between the x's. And then we learned this formula. You need to make sure that you know all of the line formulas, like the point slope formula, the slope formula, y equals mx plus b. I don't give that because that's important that you know. When you get to calculus, you're not going to be given too many formulas. You're kind of expected to know a lot of this stuff. And by the time you get to Calc 2, if you take Calc 2, then everything you kind of learn in pre-calc and trig and algebra, you use it all. You really do. And when you get to Calc 2, you start seeing where all this stuff goes, I think. So what I want to show you first of all is if I give you a table, you want to know whether it's a linear relationship or not. So what you look for is a linear function always has a constant average rate of change. So it has the same slope everywhere. Okay, that's an average rate of change is a slope. So this is what you do. If you look at this at the x values, these x values are always going up 1. Okay, so what we would expect is the y values to also go up or down by the same amount. Not up 1, just maybe they go up 3, maybe they go up 5. They change by a constant. So look what happens here. That's going down 3. That's going down 3. Everywhere is going down 3. So that means that it does have a constant rate of change, therefore it's linear. Okay, does that make sense? If x is going up in the same increment, then the y's have to go in they have to have a constant rate of change. So down 3 always makes that linear. If you plotted those points, what would happen? You'd have a straight line. Okay, that's what we mean by a linear function. Okay, right? The next one, if you look at this, okay, same thing. This is always going up 1. I think all these problems I took out of the book are going up 1. Now, if you look at your y's, let's see, that looks like that's going up 5. That looks like that's going up 3. That's going up 1. So is that linear? No, it doesn't have a constant rate of change. If you ended up plotting those points, you would have some different graph, but it wouldn't be a straight line. So it does not have a constant rate of change. Therefore, it's nonlinear. Okay, that's the idea. Everybody got that? Okay, all right. This one, same thing. Okay, it's always going up 1. Now, this thing is really just staying. Okay, it remains the same. So that is a constant rate of change. Even though it doesn't change, we would say that rate of change is just 0. But it's constant, so that's a line. So that is a constant rate of change, so it is linear. Now, what would happen on this problem if you plotted those points? You'd have a line, but what would that line look like? Yeah, that way, exactly. Okay, it would go this way. The y value would always be 8. Therefore, it's a horizontal line. Does that make sense? Okay, so that still counts as a linear function, okay? And then this last one, it's always going up 1. You can do this in your head. Does that look linear or nonlinear? What do you think? That's nonlinear, okay? This one is going up 1, then it's going up 3. It's predictable. It does have a pattern, but it's not constant. See, that's going up by consecutive odd integers. Do you know what that graph would look like? There you go. It's a parabola, right? Okay, so, and those are perfect squares. Those are squares, so that's a parabola, okay? But it's not, doesn't have a constant rate of change, therefore it's nonlinear. Okay, so that's something I want you to be able to look at and make a determination on. Okay, any questions about that? Okay, a lot of times students have learned about lines, but they haven't really looked at it quite that way. Okay, now we're only going to do a couple of examples here, and you probably want your calculator. I'm going to have you do something on the calculator on this example 3. And what this is just when you have a linear model, a lot of things are modeled by lines in the real world. So the general formula for a linear function is f of x equals mx plus b, okay? And this would be kind of a typical rental that would end up being linear, okay? A lot of rental companies do things in a linear kind of way. So what this says is When you rent a truck, it's $39.95, and then it is 0.89 per mile. Okay, what that 39.95 is no matter how far you drive the truck, you're charged 39.95. So that's going to be like a y-intercept. That's where your graph's going to start. And then the 0.89 is going to be a slope. So what you'll have is in this particular linear formula here, okay, you want to kind of think of it this way. This is kind of a variable, this would be kind of like a variable charge, I guess, on that we could say. And then this is like a fixed charge like that. So when you write your linear model, it's just a matter of putting those numbers in. So what you would have is f of x equals, and the slope is going to be that variable rate of change. So that's going to be 0.89x. And then the plus the 39.95, that's going to be a fixed cost or charge like that. So that's it. Okay, does that make sense to you? Okay, $39.95 even if you don't drive the truck at all, but every mile past that, you're going to be charged more and more money. Okay, so what this one is, real simple, this says what is the cost of renting the truck if the truck is driven 110 miles? So what you're doing is you're just evaluating that function at 110. Okay, so you would have 0.89 times 110, and then plus 39.95 like that, all right? And then that would give you the charge on that. And this is a real common practice on rentals. This is kind of the way I see most of them set up. So that'd be 0.89 times 110, and then plus 39.95, and that would give the charge. So that would be $137.85. Okay, like that. All right. Go ahead and just do the next one yourself. This is 230. And just go ahead and plug that in your calculator if you want to, and see what you get there. Okay, so let's see. I'm getting on this $244.65. Okay, so that's a real straightforward, simple example of something we would model with a linear function. Okay, like a taxi cab kind of does that as well. Okay. Okay, so I'm going to show you, the next one's kind of like a business application, which is worth showing students on in this class as well. So what you're given is this is a revenue function, so that's the amount of money that the business is bringing in from selling items, and this is what's called a cost function. So if you were going to make a profit, and you don't need to write this down, I just want to mention this while I'm thinking of it. When you make profit in a simple business, you just take all the revenue and you subtract off the cost, and that's the money you get, right? Okay, it may cost money to run your business, but you're bringing in money from selling stuff or something, okay? So what we're going to do on this is I want you to really just look at this graph. You don't need to put this in on your calculator. I'd kind of like you to make a sketch on here, but what I did, and let me zoom out on this a little bit. I just did this before class to save a little bit of time. What I did is I'm going to have you just sketch a little graph just for your, just to refer to. But what I did is this one right here, this line right here is R of X. This red line right there is C of X. And I just put those two things in my graphing calculator. And I did this window. If you want to put this in your calculator now, you can, but you don't have to. I kind of played with the window so I get a pretty good picture of it. And I made my X's go up to 8,000. So you can label this like that's 1K, that's 2K, 3, 4, 5, 6, 7, 8. So that goes up to 8,000 like that, okay? And then this right here, I made the Y's go up to like 75,000. And I made it go 25,000, so you could put 25K, 50K, 100K, because a K is just an abbreviation for thousands, like that, okay? So that's what you get. So the break-even point, you know what the break-even point would be. That's just where revenue and cost are equal. So that means once you get past the break-even point, you're going to start making profit. Your revenue is going to exceed your cost, so you start making profit. Okay, so this right here is your break-even point. And what you need to do to find that break-even point is you just set these two equations equal to each other and solve the equation. So when you do this, just do the 8x equals 4.5x plus 17,500, and then that'll give you the x value where it breaks even, okay? So that's a pretty simple equation to solve. You just would move the 4.5, so you'd have 8x minus the 4.5. X is going to be equal to 17,500, okay? And then that would be 3.5x equals 17,500. Then you can divide by 3.5. And then that'll give you the x value. You also got to find the y value of the break-even point as well. So I do 17,500 divided by 3.5. So that gives x equals 5,000. Now, if you look at my graph, okay, see if you go down there, that looks like 5,000, doesn't it? Okay, it looks like if you go over 1, 2, 3, 4, 5, that's where that x value is. And then we just need to find the y value of that. So the way you find the y value is you pick either function. It doesn't matter which, you'll get the same answer. You just plug the 5,000 into 8x. Okay, so if you want to find y, you just do, I'm going to do r, the revenue at 5,000 items. So that would be 8 times 5,000. So that would end up being 40,000. And that's a money value right there. So that break-even point is going to end up being 5,000 and then comma 40,000 like that. Okay, and if you look at your graph, that looks right to me. Okay? All right, does that make sense? Okay, so that's just a special point where you're not profiting any, but you're not losing money either. Okay, everything breaks even. That's why we call it that. Okay, now the next thing is, you don't really have to do anything on this problem. It just says find the values of x such that the revenue is larger than the cost. Well, you can look at your graph and figure that out. What happens is once you get past that break-even point, the revenue function is this thing right here. Okay, that part right there that I'm highlighting is the revenue function. So once you're past 5,000, the revenue is bigger than the cost, right? Okay, does that make sense? All of your values of revenue are on top of the line for cost. So what you would say on this, you just look at your graph, you would just say x is greater than 5,000. That would be really what that means is that's where you start making profit. Okay, so the idea here is kind of like this on this graph. Right here, you're losing money. Okay, you're not making profit. Right here, you're making profit. There, you're breaking even. Does that make sense to everybody? Okay, so you can do that problem once you get your graph done, and you can get the answer to that problem pretty easily that way. Okay, you can also solve an inequality, but it's not really necessary on that problem. Okay, any questions? These should be pretty simple, straightforward examples. You're not going to do much homework on this section, just a few examples and things that are pretty similar to this. Okay. Okay, so let's go to this next one. This is another one I picked out, let's get this done and then we'll take a break. And I also did this on the calculator. You don't need to do that unless you want to put this in your calculator. I'm just doing that mostly for reference. So with this one, this is like a tow truck. And again, that's probably a linear charge is probably the way they do this. So the cost to you, the consumer, is represented by the function c equals 2.5 x plus 85. Okay, now you know that 85 is a y-intercept, and you know that 2.5 is a slope. So we're going to kind of talk about what those things mean. So first of all, the first one's real simple. You just want to find the cost when you drive 40 miles. Okay, so basically every time you drive a mile, it costs you 2.5 or $2.50. So what you would do is do C of 40. Just plug that in and do your calculator. So we'll do 2.5 times 40 plus 85. And let's see what that is. 2.5 times 40 plus 85 will give $185. Okay, so that's the answer to that part right there. Okay. All right, and let's see. The next one says if the cost is $245 how many miles were you towed. So where do you put the 245 to solve this problem? Two choices, C or X. Which one? C. Okay, that's a cost, right? So you're going to say 245 equals 2.5x plus 85. X is the number of miles, so you've solved that equation, and that tells you how far you drive to get that cost, okay? So at this, you could subtract 85. Okay, if you did that, you'd have 245 minus 85 would be 160. Then we have 160 equals 2.5x. Then divide by 2.5. And then you'll have the answer to that problem. That should be the number of miles that you drove. So that would be, I'm getting 64 on that. So 64 miles gives you a cost of $245. That's just doing that backwards and making sure you can interpret what the meanings of the parts of this problem are. Okay, so this one says, the next question says, you have $150. That's all you've got in your budget. It says, what is the maximum number of miles that you can be towed? Well, what would you do? Yeah, you plug the 150 in for cost, right? And then it would tell you that's how much you can, that's how far you can drive your truck, okay? So you do the same thing we did on the last problem, essentially. You say 150 is equal to 2.5x plus 85, okay? And that'll be kind of the maximum there. It's the same thing. You subtract 85 and then solve that equation. So 150 minus 85 is 65, and then that's equal to 2.5x. Then you can divide by 2.5. So if I do 65 divided by 2.5, then I get 26 miles. So that's all you can afford to travel is 26 miles. Okay, does that make sense? Okay. Okay, now let me ask this question here, the implied domain. Now what that means is the domain is what is x. Okay, I don't give you a domain on this. The domain of a line is all real numbers, but the implied domain would be what is a meaningful value of x. X is the number of miles, so what's a meaningful value of x if it's number of miles? Is -2 miles okay? No, so what's meaningful? Bigger than 0, right? Okay, even 0 is meaningful. So what you would say on your domain, you could just say x is greater than or equal to 0. Okay, that's just because in the context of the problem, that's what makes sense, see? Okay, all right. All right, the slope. Now this kind of thing, you want to write this a certain way. So again, the cost function is 2.5x plus 85. Okay, the slope is 2.5. Well, let's think about what that does. Now, a slope is a rise over a run. So I take that 2.5 and put it over 1. This is what this really means. That's a change in y. So that's money. The numerator is money. That the bottom number is miles. So what does that mean? If I just asked you to write a quick sentence, what could you say? And I wouldn't say, oh, it's the rise over the run, or it's the slope. Okay, what does that mean? Every time you drive a mile, what happens? It costs $2.50. That's the way you would want to say that's like that, okay? Sometimes I'll do this like on a test or assignment and students say, it's rise over run, okay? I already know that, okay? That's not the question. So it would just say, one way to say this is each additional mile costs $2.50. Okay, when you get to calculus, your teachers will have you interpret slope a lot because you deal with slope a lot in calculus in what's called a derivative, and you really want to understand what it's doing. Okay, that's important. Okay, the y-intercept is 85. What is the y-intercept in this problem? What does that 85 mean to you? Yeah, that's just kind of like a fixed charge, right? Okay, so a lot of times the way these things work is you have a fixed charge and then the variable depends on how far you drive. So you can just say you have a fixed charge of $85. Okay, that's what the mathematical meaning of that is then. Okay? Okay, does that make sense? You guys follow what I'm doing on this okay? I think this stuff will be pretty simple for you. Okay, this is just trying to put this into a context. So let's go ahead and break until 9 o'clock. If you have any questions, you can come up during break. And when I come back, we'll do 2.2, which is very short, and then we're going to do as much of 2.3 as we can.